on. Can you hear me? Okay, I think I can see my screen now. All right. Thank you so much, Rob and Larry, for the quick introduction. Yeah, my name is Adifemi Michael, and I work as a DevOps engineer for Swisscom, which is a company based in Switzerland. But I work at the Outpost office from Netherlands. Yeah, so for today, I'll be speaking on testing with LocalStack on Terraform. So I'll just be walking us through just three basic headlines, and then I'll do a quick demo. So for introduction, I believe Terraform shouldn't be a new thing to be introduced to most of us here, if not everyone. But I'll just run through what Terraform is real quick. So as we all know, Terraform is an infrastructure as code tool. Basically, you define your infrastructure rather than doing a click on AWS console. You basically define your infrastructure using code. Of course, you can either write it in using like HCL, which is HashiCorp language, or you can write it using CDK, whichever you want to write it as a developer. And of course, Terraform is not just the only infrastructure as code tool out there. There's also tool like Pulumi, and there's also Vagrant as well, which can be used to do the same thing. And because Terraform is cloud agnostic, Pulumi is also cloud agnostic. But the interesting thing with Terraform is that, like I said, it's cloud agnostic, so it's not specific to a single cloud provider. So if you learn the language, the HashiCorp language, you can use that to create infrastructure on AWS, create infrastructure on Azure, GCP. Think about whatever you want to create, or you can even write your own provider and create something with it. Yeah, I've run through this. What Terraform is open source, so you can also clone this, refactor it the way you want to refactor it in your own organization. Like I said, it also allows users to describe infrastructure resources as code using a declarative configuration language. Yeah. So what is local stack? I think the first time I had this terminology was actually for an interview for the company I'm working for now. And then they were like, yeah, they have this, they created some sort of resource, step function, S3 buckets, CloudFormation, Lambda, sorry, I say CloudFormation, CloudWatch logs, and Lambda, and they wanted me to deploy it using LocalStack. So that was the first time I heard about LocalStack, and then I started researching what LocalStack is. Apparently, as an engineer, as a software engineer, you must have developed something that you've tested in your environment locally before, maybe an API or something using Postman. You can easily test your API out, or maybe you are a front-end developer and you deploy your application locally on your environment. Of course, you probably use Google Chrome to sort of like test out your front-end application. But this time is like, how can you test Terraform configuration? And they legitimately said I can use LocalStack to make this deployment. And I was shocked how LocalStack can actually pick up my Terraform changes, because in my head I was thinking it's going to deploy it to my cloud provider. But apparently everything runs locally on your environment. So at the back, LocalStack, you can either install it directly to your system, or you can run it in Docker, which was what I use, and which is what I'll use for this demo. And with it, you just create a Docker Compose file, state your parameters, the objects that you'll be using in AWS. I think for now, to the best of my knowledge, LocalStack works more preferably with AWS. So maybe for Azure, might not be the case, but I know they have an enterprise version. So maybe that could work with Azure. But yeah, LocalStack is also open source, just like Terraform. And it sort of like provides a way for you to manage your AWS cloud resources locally on your system. And the main purpose of LocalStack is for testing. So just like Postman, just like you having an emulator, maybe you're an Android developer or a React Native developer, and you have an Android emulator or Xcode or something that allows you to sort of like write your code and then you see it in an emulator before deploying it to production or something. So that is exactly the main concept of LocalStack. And yeah, you might ask, why should I go with LocalStack? Because I can easily deploy on my environment. But yeah, I've also seen a memes where there was these two guys sitting, and then there was this other guy that was sitting like he was extremely broke. And then the other guy was asking him, what happened? Why did you get broke? And he said he forgot an EC2 instance that was running. So yeah, so this might be the case for you or not. I've also run into that sort of issue before where I had an EKS cluster running, and yeah, that led to some sort of like cost expense on my end. So local stack is cost effective because you are deploying this locally. You don't have to worry about your running EC2 instance in AWS. You don't have to worry about your running API gateway or something in AWS. You don't have to worry about that. It gives you faster feedback. With faster feedback, you don't have to like go back and forth with deployment. Since everything is running locally in your environment, you get the output in your Docker logs. So you literally see everything that is happening, testing everything out locally in your environment. Also for improved testing as well. So if you are someone that do a lot of iterations or want to, like, you see something or you develop a new way to write maybe a for each or a for loop or something or a conditional statement, local stack can help you with that. So rather than you going back and forth switching from your AWS console, coming back to your Visual Studio Code or whatever ID you are using, you can easily see everything happening in your terminal, and you don't have to go back and forth to AWS console, and also reduce complexity as well. So yeah, I don't know if there are any other tools out there that helps with testing Terraform locally on your environment. But yeah, local stacks help you remove the complexity of thinking of how to manage deployment and all the stuff. So these are like the four reasons why I sort of like saw local stack interesting. And yeah, I have a quick demo that I would actually love to show us. So basically for the demo, what I'm trying to do is deploying a file to S3, and at the back, once the file lands in S3, it's going to trigger a Lambda function. And basically the Lambda function is not doing anything, it's just loading the file, and then that's just it. So I will switch to my second screen now, and then yeah. So prior to this, let me know if you are good. Okay. Yeah. So prior to this, to this talk, I've created I've created a Docker Compose file. So like I said, I'm running local stack in Docker. So all this just take is of course creating a Docker Compose file, stating your image, which for my image I call it local stack. The port that local stack uses most of the time is 4566. Most of all these environment variables are not needed, but I'm passing them in because I want to see the logs out here. And my Docker host, of course, is Docker. I'm using volumes because I might need some stored file. Because I'm using volumes because I'm pushing a file. I'm pushing this README. I'll be pushing this README file to S3. So I'm just needing volumes in case I delete something or I need my file back or stuff like that. But this is not necessary as well. The most important thing is to have your image and to have your port. That's like the most important thing. And maybe also set your Docker host as well. So what do I have in my main.tf? Like I said, I have a Lambda function. The runtime is Python. I've written the Python code. Like I said, it's basically just downloading the file from S3, process the file, doing nothing than just printing out the data that is in the file. And the file I'll be pushing for now is README, and I think I'll be trying with a file this file.md as well. Yeah, so I have my Lambda function created. I created an S3 bucket. I don't have to worry about the name of the bucket because this is running locally on my system. So I don't have to think about the uniqueness of the name of the bucket. Yeah, for my bucket ACL, I allow it to be public read. I created a notification, like I said, when the file drops into S3 is meant to trigger the Lambda function. So I need something that will notify Lambda that a file has dropped in S3, so which is the S3 bucket notification. Added some permission for Lambda, created a CloudWatch log group just to see if just to see the logs of what is happening in my Lambda function. Added a rule for my function as well, a policy, and a policy attachment. And for my provider.tf, yeah, I can show you this with my access key and my secret key, so you can try this on your system. I'm joking. So yeah, for my provider.tf, I have my access key, so I'm just giving it a random name. This can be any name at all. Think of anything you can ever think of and just put it in there because it's running locally in your system. Secret key and the region as well. Because I'm using CloudWatch, I'm using CloudWatch logs, I'm using IAM, Lambda, S3, and STS. So I have to also pass in all these endpoints in my provider.tf. Just this is because I'm doing it locally on my environment, of course. What else? I've shown you my Lambda function. So like I said, prior to now, I've actually done because I don't want to waste much time because this Lambda function takes a lot of time to get created. So prior to now, what did I do? We'll scroll up real quick. I did let me open my README. So in my README, I have all the necessary steps that you can use to deploy this stress-free. So in my README, I have a Docker Compose up, which of course you have to have Docker running. I have Docker Compose running in another terminal, which is this. And then, like I said, watch the logs for execution, preload. I mean, this is the amount of time it took on my system for it to load. Of course, it might take less time on your own system. And the next thing is to export your credentials. So like I said, we are deploying this locally, so you don't have to export your AWS. You don't have to use your AWS credentials on this. You can, like I said, you can create whatever in your provider.tf, passing any secret key and access key, which is what I'm also using here as well. And I'm also specifying the region. And then after that, I ran Terraform init. In my second terminal, I ran Terraform init. And then I ran Terraform plan, which is somewhere here, just to show me what I'm deploying. And then I ran Terraform apply. I'm just passing the auto approve flag because, yeah, I don't want to type in yes or no or whatever because I know what I'm writing is correct. So yeah. And then, yeah, so with Terraform apply, it creates the resources, as you can see as the output here. So 9 resources got created, which is the function, the policy, the role, the S3 bucket, the notification, and the CloudWatch log group as well. So the first thing I'll be doing is I'll be pushing this README file that I have here. This README file, I'll be pushing it to the bucket that I have created. And let's see if this bucket name is actually correct. So the bucket name is what? Test bucket 070. And I have test bucket 070 here using my S3 URL. So I'll just copy and paste this and let's see what happens. And if you look at the other terminal where Docker Compose is running, while this is getting pushed, you will see an output here about determining the main container IP, and then here the file has been uploaded to S3 bucket. Now, let's run an AWS command that lists the file in our S3 bucket. So this just lists the file in S3 bucket, and as you can see, there's a README file in S3 bucket, which was created today, some few minutes ago. And if you look at your Docker Compose, you of course see an output of the command you just ran. And like I said, we have an S3 notification, right, that triggers when a file, so we have a Lambda function that gets triggered when a file drop into our S3 bucket. Because I pushed the file, this is the output of what you are seeing because, of course, something hits the S3 bucket and then triggers the Lambda function. And of course, it's created a log group, log stream, because it's a put log event. Something is hitting the S3 bucket. You can also see the response code out here as well. And for the last command I ran, which is listing S3, you can see the response code here as well. So the next thing I have in my README for this is to actually delete the file from S3 bucket. But before we do it the file, let's check the log groups. So for this, let's describe the log group so I can grab out the name of the log group. So for the log groups, I need the log group name, which is AWS S3 Lambda, which I think I have passed here. Then I need the log stream name as well, and which will be, sorry, I need to describe the stream. So this is showing me the log group name. So I need to describe the log stream. Yeah. And if you look at my Docker Compose file as well, you can see a command like a Docker logs that shows that I ran a describe log group command. So let's grab the stream of the log stream name. Yeah, so this is the log stream name. This is the value I need to pass that in here. Yep. And then the next thing is for us to actually get log events to see what is going on in our, to see what happened with the Lambda function rewards, which I think is going to error out some stuff. But let's see. Yeah, so if you look at something happened, a request started, but this function ran, but there was some error in a particular line, as you can see here. Yeah, so there was an error that happened at this particular line, forbidding file, blah blah blah. But yeah, the most important thing is it triggered our Lambda, and then we can see the event that, of course, a file dropped into S3, triggered the Lambda, and yeah, something happened in between, which made the Lambda function to fail. But whatever happened, this is not a coding session. This is a Terraform session. So yeah, so the whole goal of cloud of LocalStack, like I've pointed out, is just for you to run this stuff locally. Imagine if I was doing this on AWS, I was deploying this to AWS. That means I will have to go to AWS to check CloudWatch, uh, see my logs, then come back to my terminal to fix the error, and then deploy again, check AWS to see what is going on, come back to my terminal to fix the error. So it's more or less like a back and forth, which is the fast feedback that I mentioned in one of the use case of LocalStack. So yeah, with this, I was able to deploy a Terraform configuration to locally to my system, and yeah, we were able to push a file to S3 bucket. We were able to see the file. We were able to grab the name of the logs because it created the log group name because it created a Lambda CloudWatch logs. We were also able to grab the log stream name as well, and we're able to see that, oh, yes, the Lambda function worked. So one last thing I would like to show, one last magic before we leave, is to actually delete the file that we have in S3 bucket. So I will use this to delete this file. And then this should run the delete command. Of course, in our logs, you will see that the delete command was run. And then I would push this file.md to S3, then I will try to run a Terraform destroy. And the whole goal of doing this is just to tell you that this stuff works just the way as how you will deploy to AWS. LocalStack works the same way, how you will deploy to your cloud provider. So if I run Terraform, if I push a file to S3 and I run Terraform destroy, of course, it's not going to destroy the bucket. And why? Because there's a file there. There's an object in S3, so you need to delete the object before you can be able to delete the bucket. So I'll show us that just to, do my last magic before I leave the call. File.md, and then let's copy this file. Let's list what is in our bucket. Yeah, we have file.md in our bucket, and here as well you will see the list command in the Docker logs output. And then let's run a Terraform destroy. Hopefully this goes quickly. But of course, the whole concept is Terraform destroy will fail. And why will it fail? Because we have a file in our S3 bucket. Yep, so it has started. Come on. Yeah, because we have a file in our bucket, and then let's watch out for what is going to happen in our Docker logs as well. So Docker logs also, as you can see, is running the delete IAM role, running the delete lambda function, running the delete policy, running the delete bucket. And if you look at the output here, it's saying bucket not empty. Now, if you go back to our Terraform command, of course, it's saying deleting bucket, blah, blah, blah. The bucket you try to delete is not empty. So this works the same way, just how you deploy to any of your cloud provider. And if you try deleting something if you try deleting S3 bucket that has an object, of course, you won't be able to delete it. So, but the most interesting part about all this is that I don't have to worry about deleting anything. I don't have to worry about my file in S3 bucket. I can literally just terminate, stop Docker, stop running the container, and then I'm good. Everything is cleaned. So if I do a Control C here, it deletes everything from my environment. So I don't have to bother about having a resource that is running somewhere, or having a file in S3 bucket or something. I don't have to think about paying AWS at the end of the month. I don't have to put all those in my head because this is local to my system. So I'll just terminate this, and of course, it's going to clean up everything and stop the container. So yeah, that is the quick demo, and let's go back to the slide. So yeah, so overall, the whole concept of LocalStack is just for you to run Terraform, and also if you are someone that is, if you are new to using Terraform or to using infrastructure as code, or to using the cloud as well, I think the first thing that should be at the back of your mind is cost. With LocalStack, you don't have to worry about cost. It helps with cost savings, like I wrote here, faster feedback, just what we saw, and then portability as well. So if you have Docker running in your system, maybe you don't have Docker, any container orchestration tool that you have running in your system will definitely work with LocalStack. And yeah, this comes to the end of my talk. Thank you.